Welcome to Tech Bytes and News, your daily roundup of articles featured in Hacker News. Today, we're diving deep into VEX RISC-V, a highly configurable, FPGA-friendly 32-bit RISC versus CPU implementation. It's a fascinating project.
I'm really excited about this. The sheer level of configurability is impressive. So what makes VEX RISC-V stand out from other RISC-V implementations?
Absolutely. The key is its plugin-based architecture. Almost everything is a plugin. The PC manager, register file, hazard controller, you name it. This modularity allows for incredible customization without sacrificing performance. It's like building with Legos, but for CPUs.
That's a great analogy. So how does this plugin system actually work? Is it just a matter of dropping in different modules?
It's more sophisticated than that. It uses an automated pipelining system. Plugins can insert data at specific pipeline stages, and other plugins can read that data later. There's also a service system for dynamic interactions, like exception handling. It's incredibly elegant.
Elegant and powerful. The documentation mentions various performance metrics. What kind of performance are we talking about here?
The performance varies wildly depending on the configuration. A small, basic implementation might achieve 0.52 dMIPS per megahertz, while a fully featured version with caches and branch prediction can hit 1.38 dMIPS per megahertz, or even more. They provide synthesis results for various FPGAs, showing a wide range of frequencies and resource utilization.
Wow, that's a significant range. And what about the instruction set architecture, ISA? What extensions does it support?
It supports RV32I with optional extensions for M, integer multiplication and division, A, atomic instructions, F, single precision floating point, D, double precision floating point, and C, compressed instructions. The FPU, in particular, is quite impressive, with support for subnormals and IEEE 754 compliance, though there are a few minor exceptions noted in the documentation.
So it's highly configurable, but also well-tested, right? How does the testing process work?
Yes, they have a comprehensive regression test suite. It uses random configuration generation to test various combinations of plugins and features. They use ISA tests from the RISC-V community, benchmarks like DH-Rhinestone and CoreMark, and even Zephyr and Linux OS tests. It's a very thorough approach.
That's reassuring. And what about debugging? How easy is it to debug the code running on VEX RISC-V?
They've got that covered too. The debug plugin allows for interactive debugging via GDB, OpenOCD, and Verilator. They even provide instructions on using Eclipse with GNU MCU Eclipse, or the older Xylem plugin. You can even debug the simulated CPU using GDB directly over a TCP connection, which is much faster than using JTAG.
That's extremely convenient. It sounds like they've thought of everything. Are there any SOCs built around VEX RISC-V?
Absolutely. The documentation details two example SOCs, Briqui and Murax. Briqui is a more comprehensive society, while Murax is designed for smaller FPGAs like the ICE40. Both include peripherals like UART, timers, and GPIO, and are designed for easy integration with OpenOCD and GDB.
This is truly remarkable. The level of detail in the documentation is impressive. It's clear a lot of effort has gone into making this project accessible and usable.
I agree. The extensive documentation, combined with the modular design and comprehensive testing, makes VEX RISC-V a compelling choice for anyone working with RISC-V on FPGAs. It's a testament to the power of a well-structured, plug-in-based approach to hardware design.
Definitely. It's a project that deserves a lot of attention. Thanks for walking us through it.
My pleasure. And to our listeners, thanks for tuning in to Tech Bytes and News. We hope you found this discussion informative and inspiring. Have a great day, and we'll see you next time.
Bye-bye.